We have NET-201. Today we're talking about access list, LAN, WAN. It's Tuesday. So we started out and we're talking about control access list, and we have a router, and we looked at this network being controlled so it cannot telnet to this network over here. Say there's some servers over there, however they may be configured. Could be one box with virtual machines on it, could be multiple boxes. So we reviewed some of the things, and that was the start, and the students then were to think about how they were going to do this, how they were going to do it. So then we said we want to stop telnet. What type access list are they going to use? Standard or extended? Students said extended. Then I asked them numbered or named. And then we emphasized the idea of what are the differences between those in terms of numbered or named. The access lists still basically function the same. Some people were confused. They selected numbered, and so we went into designing the access list. We talked about in and out here, in and out here, and some of these items we hadn't talked about yet, like this over here and here. So we created an access list to do this together in class. And we looked about the matches, and we talked about it, and we talked about then applying it right here so that we could stop the telnet traffic before it even gets into the routing table. So we're going to stop it right there. Anybody trying to telnet here to any of these over here. And we'll look at the access list here in a minute. Now, could they telnet over here? Yes, because this access list does not block it to this traffic. It's designed to just stop telnet to the traffic going over here. So we can apply it here going in. There's a couple other ways you could do that. And then later on we did, while I'm at this point, we talked about the established access list using the established bit or information at the end of the list. We talked about allowing traffic here. I use a different color. Traffic here going out to the internet, and then we can have an access list here to block that traffic from coming back in unless this access list has the established. It says it'll allow traffic back into this network as long as there has been something established going out. There are better ways to manage that, but we covered that today. Slide, we'll take a look at the access list. You can't quite see all of it here, but here in the end we said equal 23. So we created an access list 101, deny TCP traffic from this network with this wildcard mask going to this network with this wildcard mask. So wildcard mask, what we're saying is we're going to ignore the last octet, so this is going to be the match. The zeros are saying we're going to match this destination, this source. And it has to be TCP. Alright, so again, so that was port 23. And we applied that, as we talked about earlier, to that interface on the router going in. So we could stop that traffic right away. Very important, if the traffic isn't telnet traffic, so it isn't getting dropped, this statement is not true up here, then we have to have this statement because of the implicit deny. So we have to allow all IP traffic moving anywhere. Or, I mean, you could have other statements if you have more controlling things you need to do. The last thing I did is I asked the students, I said, if you have, instead of, let me draw a box around it here, instead of this source, I should have drawn that right there, instead of this source, we have this one. More or less we're saying 192, 168, 10, but we have a 3 here. So the 3 is going to tell us we're only ignoring the last 2 bits. So when we have an address here, as long as all of these bits, if they have a match, then we'll do the deny. What this in reality works out to be is only the addresses 0, 1, 2, and 3 in that network, in that last octet, will be denied, because they will be the only ones that would match this. So we can take a closer look at that later on. And that'll be it.